Hello, everyone. Welcome back to Metaphor class. So in this lesson, I want to tell you something that many students in our communication group have mentioned that they want to learn. One of the applications of this lens is in T. How do we control our camera to achieve, for example, push, pull, and pan? Then follow the play of some more advanced shots like this. So this thing is actually something we have to learn if we want to make some good works. So the case I'm showing you now is a business project I did before, which actually uses a lot of lenses. We can see that there are only 1, 2, 3, 4, 5, 6, 7, 8, even 8 shots. But this puzzle, although we have a very complicated lens, here we see that we can achieve many different effects of this kind of film. So the following is the real-time rendering, real rendering. Then we can even change a lens here. And we can have a lens like this. Follow a shot of the whale in our frame. Then this shot is more like a lens that moves. Flat is also equivalent to following our main object, but its distance may be farther. For example, the lens. We choose now. Let's look at ordering. Then choose a little lens dimension to special and there will be for example our lens and object divided. False. 8 minutes. See. A look. Immediately, when the little whale swims closer to our picture, it will leave our lens. Then to achieve a lens. This is not a lens to achieve the action switching of a subject. Let's take a look. Okay, it's off our camera now, right? Then we can see that we can design our new actions, including our lens, which also changes accordingly. We can do a shot of lifting up here. And then the whale swims down again from the top. Such a change. Then we are going to switch a scene. We can switch a scene through such a shot, right? Then at this time we continue to let our whales come out of the picture, and this is also a follow-up shot, right? But we follow it from behind its buttocks and move through a lens, transformed it to the side of our main object. Why does such a change turn to the side? Because of course, this is an immersion space. We should read it, right? Our surroundings. Then all beacons are ancient, right? So in this lesson, we'll explain to you a lot of things that them say in T. And then of course it will not be so difficult to learn all of a sudden, except for what we saw. In addition to the basic lens that Putpulhang just mentioned, we can see that it is actually driven by data. There are a lot of data to judge. When we are at right time. Okay. So NT will tell you about a relatively basic lesson we're going to learn in this lesson. How do we achieve an effect? Well, this is a case that we are going to use in this lesson. Let's see that we have some subjects. Right, let's turn off backward. For example, how do we achieve the most basic push and pull? Just pull back, right? Then I push forward. Such a shot, and then, for example, how do we achieve a shake? Including shaking. There are different shaking methods, right? It's not just a fixed shaking method of our camera. For example, our main object is fixed. And we will learn such a shaking method in this lesson. And for example, this is a following effect. And the reverse direction is reversed. Our lens follows our main object to move. and then our camera will follow it. In fact, we have basically covered all of these basic changes of a lens. In fact, we can master the changes of lenses. We can also learn something advanced in this lesson. Then we will learn in this lesson these. A brand new TD. Because our little squares must be very important in this lesson. Right? We need to build all the things we want to shoot. Adjust a ground of 100 by 100, and then change the orientation to the ZX axis. In this case, it is a plane. Then we spin it up and make it move. And use this to make it spin. Alright, we see it already spinning, right? Alright. Let's hit the little plus sign and turn off its active status, then we use GM to render it. Then put our main character today, which is a camera. Then put a light. And finally put a render. Okay, and then we show it through a no. Okay, and then we give it a material. And then we throw it on the geometry. It has this material. Okay, then we go to light, and we click on the plus sign in the lower right corner. Then we rotate it a little bit so that the light comes from the top right of it. Okay, and then we're going to, why I don't see our ground right now. Our ground is 0 on the y-axis of 0, 0, 0. Is the y-axis of our camera also 0? We can see it. We go to light, we go to shadow. That is the shadow to head hard. Okay. And then we create an RGB to add a black background to it. Okay, we want the dark part that I think is dead black. We want to copy. We copy a light. Then we let light shine on our dark part. The dark part of our square. And then turn off its camera. Then we turn down the brightness a little bit. A good 0.3 so that our dark part will not be too dead. It's dark. We put 2 more references. We put them on the box and then we copy another one. Then we put 2 teleports in the back. Okay. And then we connect both of them to our position. We right-click on all of them, and then we connect them at the same time. Okay, and then we send it here. We send it one to the left, and then we send it one to the right. Okay. To make these 2 a little bit smaller, let's give him a U style of 0.7. Okay, so we have 3 little squares, right? Okay, so now, our first part today is push and pull. How do we make our lens go forward and backward? In fact, it is very simple. We create one here and we create one here. I made, which allows it to increase and decrease at will. It is very simple, but we are very long. If you want this plugin, you can send me a private message in the background of these materials that we get this thing by sending a private message in the background. Okay, then we can look at it. If you don't want to bother to get it, just look at it. In fact, there are 2 counts. In this way, when we input 1, it will increase, and when we input 2, then we have an indirect filter in the middle. And then a mask after the future to control our data range. Okay, in fact, push and pull is the simplest way to move the lens here. We just need to throw our data values on the z-axis of our camera, our XYZ axis. Right? In order to make it easier for everyone to see clearly, I will open a MTV here so that we can see more clearly. We see that the one we selected here is our camera. Forward and backward on this axis. Okay, we're here at max, and we're going to slightly increase its data range, and we're going to change it to a 5 to 10. So it starts with 5, and every time it goes to 1, or down by 1. It goes up by another 5, right? And then we throw it on the z-axis. Okay, let's press the keyboard at this time. Let's try it by pressing the keyboard with this plugin. You pull back our lens. And then we press it again, and it will achieve a good push effect. We just saw what happened when my lens kept pushing forward, even beyond our theme library. Who knows? When we see our camera, it is behind our main object, and it is not facing our main object. We will create a comp. It is equivalent to creating a point here. So what does it look down to know in our current picture? In fact, it is equivalent to that we can see very clearly when we look here. Come up, come up. That's what our cameras are looking at. All right, let's push him back. In that case, no matter how we move our cameras, it is always facing our main object. In fact, it is not facing the main object. Let's talk about how to make it always face our main object. That is, to the part we follow. Follow the part of the main object. So now we have learned how to do push and pull. Right? Okay, let's go ahead and cancel the data mapping we just did. The second is shaking, right? We need to shake our picture. What is shaking? So that we can look at our picture from left to right. This time, let's think about it again. As we said just now, we made our camera face a point at this, our trouble. Then we are in this place, and we can control the location of the noise. We have shift left and make it keep moving for camera. Let's find out the noise we just made. Then let's axis and the axis, and we need to move left and right. Does it realize the left and right shaking of the camera? Okay, we can control it through our data, right? Let's just let it have 1. Right, we can see that it is a change from -1 to 1. Okay, let's put this number, let's put ours to 0 first. So, we have realized the shaking of a picture. We see that our camera is constantly shaking from side to side. Move our camera, which is equivalent to drawing. Just now, we drew a circle. And we directly cancelled the mapping of no just now. Try this again, so that we can realize what we just said. 1. For a different angle of the target point. Right? Shake it. Step 1. It's time to move. We're gonna move our camera. Move us than just now. Because we are going to move. Which means our main objects are constantly changing and moving, right? We are going to follow the horizontal movement of our main body. At this time, we don't need these two. We delete the 2 on the side of it. Then we make a new reference object. And we make a lot of fences for the reference object, so that we can see more clearly. Let us know that our subject is moving. Otherwise, there is no reference around now. We can't tell it's moving, can we? Okay. Then we create another line. Just do this with me. And then we just go to 2. And we open its instance. Then drop the line on the translate up. Then we put the corresponding x-axis as P0. And then P1, P2, XYZ corresponds to 0, 12. Okay. Then let's move on. Let's adjust a position of line. We change it's a point, we change it to a -20. Then change a point B to 20. Okay, in this case, our 2 points, our box is distributed on the 2 points of the line, right? Okay. In the middle of these 2 points. Okay, and then we're going to shrink it. And our box is going to let us see it clearly. So we can see it clearly, right? And then we rate the height so that it fits in more clearly, right? Okay. Let's zoom out a little more. Okay, in this way we have a fence. And then we look, but because it's still at 0, we're at 0. We're going to move it back. Then it becomes a -4, respectively -4, both -4. It's right behind our boss. Okay, so Yao, we have to let him go. From the send to the send. Let our boss make a move, and move forward first. For example, -20. From -20 to 20. This is still directly using our plugin. And we create another one after future. No, we just use max. We turn it on and then change it from 0 to 1 to a range of -20 to 20. And then we throw this number on the 2x axis of the center. At this time, when we press the keyboard 1, he can walk a little slower. Very good. Okay. Now we're going to make the camera follow movement of our little cube, right? At this time, let's think about it. So our node and camera are relatively static. Their positions are relatively static. And we go directly to the center. Then we choose Copy Company on the whole English center. In this case, we can copy to a date position of its 3 axis. Then we copy it directly to our translate and copy it. Okay, how about this? Or no, the direction we just looked at, that is the position of our camera. It is exactly the same as our box, right? If we let him come like this at this time, he's our camera, and he's totally following him. Okay, what are we going to do now? What we do now is make our camera move the square, right? We still directly copy the parameters of the number. Just copy to the translate up of the camera. Let's choose pass from here. Let's take a look. In fact, it is because the 3 points of our camera are completely overlapped, right? Don't need to completely coincide. We need to make the z-axis of the camera slightly to the side. So we can put a 5 after the z-axis. And then it will come out. Right? Okay, let's try it again. Let's click 1 on the keyboard. I'm going backwards. I'm going back.